this we will study viscosity and surface tension. So first we are studying about viscosity. So fluid friction is basically what is called as viscosity. The friction existing in the case of fluids, that we call it as viscosity. And what is the reason for this viscous forces? Reason for this one is the interatomic and intermolecular forces. So these interatomic and intermolecular forces are responsible for developing the property of viscosity. Now, before studying how this viscosity works, first of all we should study about cohesive forces and adhesive forces, which come under types of forces. So first we will discuss about cohesive force. So the force of attraction existing between similar molecules is called cohesive force. So what is the meaning of this one? For example, if you take two water molecules, so always there will be some force of attraction between these two water molecules, and these two water molecules are similar molecules. So such type of force we call it as cohesive force. Similarly, next we should study about adhesive force. So force of attraction existing between molecules or dissimilar molecules is called adhesive force. For example, if you take force of attraction between the container molecule of the container and water molecule, so this type of force we call it as adhesive force. So because of this adhesive force only, we are able to write with the help of a chalk piece on a blackboard. So chalk piece is having a molecule of CaCO3, calcium carbonate, and blackboard paint, it is made up of a polymer. So force of attraction between these two dissimilar molecules, so it is called as adhesive force. Now, after studying these cohesive and adhesive forces, now we will study the property of liquid flow. So, property of liquid flow. So, here we can write that liquid always flows in layers if it is streamline. So what is the meaning of a streamline? So streamline flow we can define like this. For example, if a particular liquid is flowing in a pipe, then let us take some particles A, B, C and D. So these molecules, considered they were moving in this direction and their order was present like this, A, B, C and D. Now after a time of T, if I have observed the flow of these molecules, then after some time also their order has not changed. It means that one molecule is not jumping over the other molecule. So this type of flow we call it as streamlined flow, or I can call it as regular flow, or I can call it as laminar flow. So if a flow is streamlined, then liquid always flows in the form of layers. So therefore it means that one layer is flowing over the above layer. So for example, let us take how liquid flows in the form of a river. So consider this is the bed of a river. So this is the river bed. So on this one, this is the first layer of water, second layer of water, third layer of water, fourth layer of water, and let it be fifth layer of water. So just now we have studied that if flow is streamlined, then fluid always flows in the form of layers. Now if I take this bottommost layer, so here a molecule of water is present and here a molecule of soil is present. So in between those two molecules, what is the type of force? So this type of force existing between them, we can call it as adhesive force. So this force of attraction, which is called adhesive force, it is very stronger between a water molecule and a molecule of the soil which is present here. So therefore this bottommost layer, it will be almost in rest position. So bottommost layer will be always in rest position. Its velocity is 0. Now if I check the velocity of the layer which is just above this layer, then let us call it as its velocity is v1. Similarly, if I check velocity of the water layer which is above this layer, then it will be having a velocity of v2. Similarly, if I check one more layer, it will be having velocity of v3. Similarly, if I check one more layer above this one, it is having a velocity of v4. Then why I am drawing this arrow marks like this? It means that so the topmost layer v4, it has a greater velocity when compared to v3, and it has a greater velocity when compared to v2, and this has a greater velocity when compared to v1, and final layer is in rest position, its velocity is 0. It means as I move upwards, continuously the velocity of the layers will continuously increase. So topmost layer has the highest velocity and the bottommost layer has the velocity of 0. So this is how liquid flows always in the form of layers. Now if I study this topmost layer and the layer just below this one. So if I take this velocity, its velocity is v4, and the velocity below this one, the layer is traveling with a velocity of v3. Now if I take two molecules, which one molecule in the topmost layer and one molecule in the bottommost layer, so this molecule relatively it has a greater velocity when compared to this molecule, and this molecule has a relatively lesser velocity when compared to the top molecule. Now if this molecule is moving with a greater velocity and here forces of cohesion are present, cohesive forces are present in between these two molecules. So this molecule has a higher velocity and this molecule has a lower velocity when compared to this one. So as the topmost layer, as it is trying to move with a greater velocity, along with this molecule also tries to pull the molecule below this one. Or in another sense, by Newton's third law, I can say that the molecule which is below this one, which is having a lesser velocity, it is trying to pull the topmost molecule in opposite direction. So that is, top molecule is pulling the bottom molecule in forward direction, or I can say bottom molecule is pulling the top molecule in backwards direction. So these forces will act until the relative motion between these two layers has become 0. So this property of the liquid is exactly what we call it as viscosity. So therefore, how can I define viscosity? Viscosity can be defined as the property of liquid by which it tries to destroy the relative motion between two layers of liquid. So viscosity is the property by which it tries to reduce the relative motion between these two layers of liquid. So one molecule is pulling the other molecule, another molecule is pulling the topmost molecule in backward direction. So these forces will act in opposite directions as there is relative motion between these two layers. So when there is no relative motion between these two layers, these molecules, they will not pull them in opposite direction. So these viscous forces, they are trying to continuously reduce the relative velocity between them. What is meant by relative velocity? Let us see. So let us consider this top layer is moving with a velocity of 1.5 meters per second, and bottom layer it is traveling with a velocity of 1 meter per second. Then relative velocity between them is 1.5 minus 1 is 0.5 meters per second. So when external forces are not acting, these viscous forces, they continuously try to reduce the relative velocity between them, and finally the velocity of the liquid will become zero. So this property is exactly what is called as viscosity. And this property, it is not a constant for every liquid. For example, if you take water, if water is flowing in the form of layers, then the cohesive forces between two water molecules is lesser when compared to the two molecules of honey. For example, these are two layers of honey which are flowing, and these are two molecules. So here cohesive force between two water molecules is lesser when compared to the what you call the force of cohesion between two molecules of honey. So therefore, if I pour honey and water on a table, then I will see that water travels comparatively a larger distance when compared to honey before stopping. Because in the case of honey, because of strong cohesive forces, I can say the intermolecular forces are stronger, and therefore viscosity of honey layers is greater when compared to the viscosity of water layers. So this property is exactly what is called as viscosity. Now we will study about Newton's law, where we will discuss how these viscous forces, they depend upon. Simon. So Newton gave this idea of viscosity. Clear? So we have studied that liquid always flows in the form of layers, no ma? Clear? For example, if you take this one as the topmost layer of water and this one as the bottom layer of water. Are you able to understand? So liquid flows always in the form of layers, no? So this is the top layer, this one is the bottom layer. Then experimentally it was proved that frictional forces between, or viscous force between these two layers, it is directly proportional to area of cross section, or area where these two liquids are touching with each other. Are you able to understand me? So viscous forces are directly proportional to area of contact of these layers. Are you able to understand? If more layer is touching another layer which is whose area is also greater, then it is experimentally proved that frictional forces are increasing, or viscous forces are increasing. Clear? So this is one experimental result. Similarly, this is one layer, this is another layer. So this is traveling with a velocity of v1, this is traveling with a velocity of v2, and their distance between them is dx. Then what is v1 minus v2? Velocity difference, no? So which I will call it as, if velocity difference is small, then I will write it as dv. Then viscous force is also proportional to velocity gradient. What is meant by velocity gradient? So F is proportional to dv divided by dx. dv means change in velocity. dx means distance between the layers. Are you able to understand me? So viscous forces are proportional to these two conditions. If larger areas are in contact with each other, then viscous forces will increase. Similarly, if dv by dx is greater, then also viscous forces will increase. Are you able to understand me? For example, if velocity is 2 meters per second, this velocity is 1 meter per second. Understand? In second condition, velocity is 4 meters per second, velocity is 1.2 meters per second. So in which condition viscous forces will be greater? Can you say? In first condition, these are the two velocities. Top layer is having a velocity of 2 meters per second. Bottom layer is having a velocity of 1 meter per second. In second condition, top layer 4 meter per second, bottom layer 1.2 meter per second. Clear? Then in which condition viscous forces are greater? First condition or second condition? Second condition. Why? 4 minus 1.2 is a greater value, no? 2 minus 1 is how much? 1. 4 minus 1.2? 3.8, 2.8. Clear now? In second condition, dV value is greater. So if difference of velocity is greater, then also viscous forces will be greater. So these are the experimental results which were obtained by Newton. Are you able to understand? So if I combine both of them, then how can I write? Then I can write F is proportional to A dV divided by dx. I can write like this. Okay. And for this one, we should calculate one constant also to remove this proportionality symbol. And what is that constant? That constant is eta, A dV divided by dx, where eta is called as the coefficient of viscosity. Clear, ma? And this eta value, it changes from liquid to liquid. Different liquids will have different coefficient of viscosities, no? So if eta value is greater, what is the meaning of this one? It means that viscous forces are also greater in that liquid. So therefore eta is called as the coefficient of viscosity. Are you able to understand, ma? So definitely I can say eta value of honey is greater than eta value of water. Honey is a very dense liquid, or you can say very viscous liquid. Very easily it cannot flow. It means one layer of honey cannot flow easily on another layer of honey, because very strong forces of attraction will be present between one honey molecule and another honey molecule. Clear, ma? So if I flow both of them, which one will stop easily? Honey will stop easily, because very strong forces are acting, no? So just after traveling some distance, it will stop. But water will travel a greater distance. Are you able to understand, ma? So this nature is defined by coefficient of viscosity. Are you able to understand? So this is analogous to rigidity modulus also. In elasticity, we have studied rigidity modulus, no? Or shearing modulus. What is meant by rigidity modulus? For example, this body is fixed to the ground. Here if I apply the force, then shape of this body will tend to change, no? Or topmost layer of this block, it will try to slide. Immediately opposing forces will act. This is the sliding in the case of solids. This is the sliding in the case of liquids. So these two terms, they are analogous. Rigidity modulus and coefficient of viscosity. Are you able to understand, ma? So make a note up to here. So this is our equation for viscous forces. F is equals to eta A dV divided by dx. Clear? And this viscosity, it has units. In SI system, it is measured in poisjoule, or we can call it as decapoise. Clear, ma? In CGS system, this coefficient of viscosity has the units of poise, and relation between them is 1 poisjoule is equals to 10 poise. This is the unit of coefficient of viscosity. Clear? Go. Okay, ma? So differences between static friction and fluid friction. What is meant by static friction? Friction existing between solids, that is called static friction, and friction in liquid is called as viscous drag, or you can call it as fluid friction also. Are you able to understand, ma? Okay. Now, fluid friction depends on these parameters, no? F is equals to eta A dV divided by dx. So, fluid friction depends on area of cross section. But static friction, will it depend on area of cross section? See, for example, if I take a block like this and place in this method. Similarly, same block, if I place like this. Okay. So frictional force, will it change or will it not change? I am applying force in this direction. And here I am applying force in this direction. Body is ready to move. It means equal amount of limiting friction has developed, no? Clear? So this is FL1, this is FL2. Are they equal or are they different? Definitely they are equal. Because limiting friction in solids does not depend upon area of contact. It depends on what? Limiting friction only depends on normal reaction and coefficient of friction. That's all, Rama. So therefore, this fluid friction depends on area of cross section or contact area of the liquids. But static friction does not depend on area of contact. This is one difference. Are you able to understand? Similarly, F is equals to dV divided by dx in the case of liquids. What is meant by dV divided by dx? It depends on relative velocity between the layers of liquids. But for example, this is one body which is traveling with a speed of 2 meters per second and ground is in rest position. Similarly, this is one more body which is traveling with a speed of 4 meters per second and ground is in rest position. Clear? Now in this condition static friction will be greater, or in this condition static friction will be greater? In both the conditions static friction remains same, or kinetic friction remains same, because friction depends on what? Again mu s into n, these two are constants. Are you able to understand, ma? So static friction does not depend upon relative velocity of two bodies, but fluid friction does depend upon relative velocity of two layers of liquids. So these are the differences. Are you able to understand, ma? Okay, make a note of this one. Write in your own terms. Of temperature on viscosity. So temperature, it will show different effects on liquids and gases. Clear? For example, if you study about liquids, then here viscosity is inversely proportional to root T. What is meant by inversely proportional to root T? As temperature increases, viscosity decreases in the case of liquids. Clear? Or at boiling point. Boiling point means what? That is only for water. Remaining fluids, remaining liquids are also there, no? Boiling point means it is the temperature where liquid state of the liquid is converted into gaseous state. At that condition, coefficient of friction will become 0. So viscosity completely becomes 0. Are you able to understand, ma? But if you study in the case of gases, then for gases coefficient of viscosity is directly proportional to root T. What is meant by directly proportional to root T? If temperature increases, viscosity of the gases will increase. Because if temperature increases, gases, they start traveling with a higher velocity, no? If they start with traveling with higher velocity, then they will give huge amount of forces on the body which is traveling in this gas. So automatically viscous forces will increase. Are you able to understand, ma? So this is how temperature changes in the case of liquids as well as gases. Clear? Okay. Now we will study about the last topic in viscosity, which is called Stokes' law. So what is meant by Stokes' law? Here we write the equation of force experienced by any body traveling in a liquid or in a fluid. Clear, ma? Viscous forces experienced by any body is called as, that is given by this equation which is called Stokes' law. Clear, ma? For example, this is the liquid in which this body of radius r, it is traveling with a velocity of v. Clear? Then this body will be wetted by the molecules of this liquid, no? Molecules of this liquid will be surrounding this body. How they will be surrounding? So all the molecules, they will be attached here. Understand? And these molecules, they will be always in rest position with respect to body. Okay. But other molecules, they are in movement, no? Or if I say if all the molecules of liquid are in rest position, these molecules, they are in movement. Why they are in movement? Because they are attached to the body. Because of which kind of forces? Adhesive forces. Adhesive forces will be there between molecules of liquid and molecules of this body, no? Those forces we call them as adhesive forces. Okay, ma? So these molecules are moving, but remaining molecules are in rest position. Understand? And between the remaining molecules and these molecules, there will be again cohesive forces. Cohesive forces will be present, no? So these cohesive forces, they try to pull this body backwards. Are you able to understand? If body is moving forward, cohesive forces will pull the body backwards. So again, frictional forces are existing, no? So this type of forces are existing on this body, and equation of this type of viscous forces experienced by this body is given by 6 pi eta r into V. This is the equation. Clear, ma? So eta, what is eta? Coefficient of viscosity. What is r? Radius of this body. Similarly, what is V? Velocity of this body. That's all, no? So here there is one important property. Here, as velocity increases, viscous force also increases. If body is traveling with a greater velocity, then viscous forces acting on this body also will increase. Are you able to understand? So that is the reason why if you, what you called, fire a bullet in water, bullet cannot travel a distance greater than 10 meters. Understand? What is the reason? Because initial velocity of bullet will be very high, no? Nearly 500 meters per second. Clear, no? If velocity increases to a very large value, then what will happen to viscous forces? Viscous forces also will increase. So very fastly, the velocity of this bullet will reduce. Understand, ma? So this is called as Stokes' law. Okay? So this completes our theory part on. Okay. See, so velocity of water in a river is 5 meters per second at the top surface, and width of the river is, that is depth of the river is 10 meters. Then we are supposed to find out what is the shearing stress in between adjacent layers of this water when coefficient of viscosity of water is 10 power minus 2 poise. That is the question. Okay. How can you do this one? How can we do? Shearing stress we are supposed to find out. Clear, ma? See. For example, if you take this one as top layer of water and this one as bottom layer of water. Okay. So already we studied yesterday, no? Bottom layer of water will be almost in rest position. Okay. And the topmost left the layer of the water, it will be traveling with the greatest velocity or with the highest velocity. And that velocity he gave, no? Topmost layer of water, it is traveling with a velocity of 5 meters per second. That's all, no? And this layer is in rest position. Now what is the distance between these two layers? Distance between these two layers is 10 meters. That's all, no? Then he is asking to find out the shearing stress. What is meant by shearing stress? Shearing stress means shearing force per unit area. That's all, no? Shearing force per unit area. So can you say that shearing force is applied on this river layers or not? Definitely shearing force is applied, no? Then only one layer will flow over the other layer. This is exactly what we studied in rigidity modulus also, no? Modulus of rigidity. What we have studied there. For example, this is a body which is fixed to the ground. Bottom layer is in rest position, just like river. That's all, no? And we are applying force at the topmost layer. Then which area I have to consider? This is a tangential area, or area to which this force is a tangent, that is topmost area. Then what is the shearing force? Now shearing stress is how much? Shearing force per unit area. This is how we have calculated, no? Are you able to understand, ma? So same concept we are applying in the case of river also. Same concept. Clear? Now how can I calculate shearing force per unit area in this condition?
Shearing force F equals to A dV by dx.
So shearing force is how much? F is equals to eta A dV divided by dx. This is what we studied, no? So viscous force between two layers, or layers which are separated by a distance of dx. Then what is the viscous force? Eta A dV divided by dx. So from this one, how can I calculate the stress? Take this area to this side, that's all. No? So force per unit area is nothing but eta dV divided by dx. This is nothing but, this is nothing but shearing stress. No? So therefore, stress is equal to eta. Eta value is how much? So 10 power minus 2 poise. What is meant by poise? Unit of coefficient of viscosity in terms of CGS units. Then what is the unit in SI unit? Decapoise or poisjoule. So what is the relation between poise and poisjoule? 1 poisjoule is equal to 10 poise. This is what we studied yesterday, no? So therefore 1 poise will be how much? 1 poise will be 1 into 10 power minus 1 poisjoule. That's all, no? This means if this poise, if I multiply by 10 power minus 1, it converts into SI unit. Are you able to understand? So therefore, stress is equals to eta value is 10 power minus 2 into 10 power minus 1 into dV. What is the change in velocity between these two layers? Bottom layer is in rest position. Top layer is traveling with a velocity of 5. Then what is the change in velocity? 5 minus 0. So 5 minus 0 divided by, now dx means the distance between these two layers. No? Distance between these two layers is nothing but 10. So just to do this calculation, that is our answer. That's all, no? So what is the answer you should get? 5 into 10 power minus 4 Newton per meter square. That's all. That is our answer. Have you understood, ma? So everything we are doing according to this equation. F is equals to eta A dV divided by dx. Clear? Come on, make a note of this one. Okay. So Sima. So there is an oil film whose thickness is 2 millimeters. Clear? Or consider this is the oil film. And what is the thickness of this one? Thickness of this one is 2 millimeters. Clear? So on this oil film, we are placing a plate of area 100 centimeters square. So what is meant by plate? So let us consider this is the plate which I am placing. And its surface area is how much? 100 centimeters square. Okay. Then if coefficient of viscosity of oil is given 15.5 poise, then I want to move this plate with a speed of 3 centimeters per second. Are you able to understand, ma? On this oil film, we are placing a plate. That plate I want to apply some force and I want to move it with a velocity of 3 centimeters per second. Then what is asking? Then what is the force required to move this plate with that much of velocity? That is the question. Okay? Think how you can do. So can you say what is happening here? What is happening? Sim. Same equation we use. Question is, why we have to apply force here? Why I have to apply force on this plate for moving this one with a speed of 3 meters per second? What is the reason? Why should I apply the force? That is the question. Okay, Sima. So this is the layer of oil which is present, you know. Okay, this layer, it will be attached to the table. Bottom layer will be attached to the table, and bottom layer will be always in rest position. That's what we studied, no? In any kind of liquid, bottom layer will be always in rest position. And above this oil film, we are placing one plate. Clear? And the molecules of this oil, they will be attached to the molecules of the plate, no? Molecules of the oil will be attached to molecules of the plate. By what kind of forces? Adhesive forces. Okay. So if I want to pull this plate in this direction, definitely I have to overcome the forces of cohesion between oil molecules and the oil molecules. Oil molecules which are attached to the plate, and the oil molecules which are present below that oil molecules which are attached to the plate. Cohesive forces will be present. No? To oppose that forces, definitely I have to apply some shearing force. That is what is happening here. Are you able to understand? So same equation. So force equation is how much? F is equals to eta A dV divided by dx. So eta value is how much? 15.5. Area of cross section of the plate, area of the plate is 100. Now what is the difference in velocity? Bottom layer will be in rest position, no? For any liquid, bottom layer will be in rest position. Topmost layer will have a velocity of 3 centimeters per second. So dV value is 3. dx value is how much? What is the thickness of the oil film? 3? 2 mm. So in terms of centimeters, how can I write? 2 into 10 power minus 1 centimeters. That's all. So do this calculation. That is the amount of force which is required. That's all. So that what is the answer given? F is equals to 2.235 into 10 power 4 dynes. So this much amount of force will be required. Okay. So if you want to convert this one in terms of newtons, how can you write? 1 Newton is equals to 10 power 5 dynes, no? So same relation, how can I write? 0.2235 into 10 power 5 dynes. So 10 power 5 dynes is 1 Newton. So 0.2235 into 1 Newton, that is 0.2235 Newtons. That much of force is okay. Sim. So this is a table to which we are fixing a fixed pulley here. Understand? And one end of the string, it is connected to a plate or any mass whose base area is how much? 0.10 meter square. That is the area of the plate. Clear, ma? And below that plate, there is a film of oil. Some film of oil is present, whose thickness is 3 millimeter. Okay. And other end of the string, it is connected to a mass of 0.01 kg. So if I release this system, then this system is traveling with a constant speed of 0.085 meters per second. Then what is the coefficient of viscosity of this oil? That is the question. Eta value I am supposed to find out. Okay. Think how you can do this one. First, if I draw the forces which are acting here, then weight of this mass will be acting downwards, no? Weight of this body will be acting downwards. And what is the upward force which is acting? Tension. Same tension will be pulling this plate also in this direction, no? So here if tension is T, here also tension will be T only. So this is the tension which is pulling this body in this direction with a speed of 0.085 meters per second. Okay. Now what is meant by constant speed? The system is moving with a constant speed. Constant speed means what? Speed does not change. Speed does not change means? Velocity is not zero. Huh? Acceleration is zero. That is the meaning of this one, no? This is a non-accelerated motion. Uniform motion. Clear, ma? So if I draw the free body diagram of this one, this is how I can write, no? Tension is acting upwards. Mg is acting downwards. So body is coming downwards, no? So which force will be greater than which force? Mg minus T is equal to Ma. That's all, no? This is how I write the relation when bodies are coming down. Generally Mg should be greater than tension. So Mg minus T will give the net force. Net force formula, mass into acceleration. But here, this is non-accelerated motion, no? It means acceleration value will be how much? 0. So Mg minus T is equals to M into 0. So Mg minus T is equal to 0. So Mg is equal to T. What is meant by Mg is equal to T? It means weight of this body and tension both are equal. That is the meaning of this one. So same tension is acting here also, no? Then now can't I calculate what I want to calculate? Coefficient of viscosity. So tension is nothing but force. Coefficient of viscous force, F is equals to eta A dV divided by dx. That's all. So F is nothing but tension. Tension is how much? Mg is equals to eta A dV divided by dx. From this can't you calculate eta value? Remaining all values we have, no? That's all. So eta is equals to mg into dx divided by A into dV. So substitute all the values. That should be our answer. That's all, no? Come on. So eta is equals to mass is how much? 0.01. G value is 10. Dx. Dx means thickness of oil film. Thickness of oil film is how much? 3 mm. If you write in terms of meters, 3 into 10 power minus 3 meters divided by area of cross section of the plate is, base area of the plate is 0.10. Velocity. With what velocity system is moving? 0.085 meters. So calculate this one, then you should get 3.4 into 10 power minus 3 Poisson. That is our answer. It's all very simple.